All right, well, welcome to, this is going to be a presentation on combining functional testing and performance testing together. Now, who was in my last session, my session? All right, this is going to be a little more boring. I don't have any watermelons or cards. So you can leave now if you're, no, I'm just kidding. All right, so you better really good last session. How was your last session? Everybody else was in a different session. Was it good? Learned some cool stuff? Hopefully. If nothing else, when I go to a conference, I don't really learn as much as I'm validated. It feels good to be validated. You go in and you say, you know, you should be doing this. You're like, yes, that's what I told my company yesterday. I'm validated, you know. It doesn't feel good to kind of check your learning against other folks and so forth. So this is going to be another interesting presentation. It's going to be talking about, I'm going to be talking about a practice that I don't recommend, but it can be done. And it's actually a case study where I actually did this for a client. So let me put my little thing in here. Hang on. All right. So before I get started, my name is Chris Lawson. There we go. There's me. A mugshot. When I was in the other room, in that big room, man, my head looked giant. I'm like, God, my head look that big in real life? Oh my gosh. No comments, Jim Bruce. All right, so this is going to be on, combining performance testing and automated functional automation together in a single practice. And my last presentation talking about evolving, evolution, and this is going to kind of take on that same theme too, how we can start somewhere and evolve the practice. So this is not an end, ought to be, holy grail thing. This is just some ideas to get you started. And so before I start though, how many of you in here are doing some form of functional test automation in your company? You know, it could be like Quick Test Professional, commercial tool, or Selenium, anything like that. Got 1, 2. Okay, 2. All right, what about performance testing? You guys do some level performance testing? Got 2 more, got different too. I know you are too, Tommy, some level performance testing as well. So the idea is that typically performance testing is done by engineer A, and the functional automation is done by engineer B. Well, you're just looking at a guy who's done both and can do both. In my career, I've been in this business for about 20 years, and I started my career out on the functional automation side, and then I went to work for a company, and they said, "Oh, you know how to do functional test automation? We're going to send you to Load Runner School and learn how to do performance testing." Because that makes perfect sense, right? You know, it's like saying I can code, and therefore I can develop software too. I mean, come on now, it's not what my skill is. So I had to learn really quickly, right? Networking protocols. I had to learn some really intricate things. So this is a really cool kind of introduction to performance testing for those who are not familiar with it. For those who are familiar with it, then I'm going to talk about introducing you to the functional side. So I'm taking my two worlds and I'm combining them together and saying, hey, look, check this out. This is what I did. There's a company in Raleigh. They hired me to come in to build an automation framework, and we were using Selenium and Java, and you're going to see some code snippets in a few minutes of extra code. We're using Selenium and Java. So I came in, I architected a solution out for them for automation, and we automated several hundred of their tests, the regression tests for them. And they liked what we were doing so well that, so I architected it, and then I had a senior engineer and a junior level engineer actually build out the test and the actual framework itself. So then they realized what we were doing, and the manager one day looked over and he said, wait a minute, I've got like hundreds of these tests, that work really nicely. If I were to run these same tests in kind of a load test fashion, could we do that, Chris? Could we run these functional tests to generate load on our application? And I did what every good consultant does at that point. You have my attention. So I said, well, no, actually, we really shouldn't do that. But, this is kind of my presentation here. So I'm going to talk to you about what I did, what my experience was, and what I learned. Okay? That's what this idea behind this is. That's where it comes from. This is a presentation from the streets of the world at which I live. All right, so what we're going to do is we're going to look at, a couple of concepts here. This is going to introduce you, for those that are not familiar with functional automation or performance testing, it's going to give you a good introduction to those two worlds. And we're going to talk about what that looks like. We're going to talk about some common modeling techniques. Those that are in the performance testing world will recognize some of these modeling techniques. They're very much industry standard best practices. And then we're going to talk about the method or the methodology that I use to combine these two together and how they all work together. So it's an interesting little outcome, and I'll tell you what the outcome was in a minute and give you a final word of advice on what to or not to do, okay? And I see Norgon. Are you from Norgon?
Yes, sir.
Keith Bennett?
Yes, sir.
Okay, I know him. Good friend of mine. He actually texted me and says there's a couple guys coming from Norgon, so
Yes,
a couple of people, so anyway, tell them I said hello.
I will.
And I did some load testing for Keith and some functional automation for him as well, you're not guaranteed. All right, so we're going to talk about what I did and how you can do that, and so forth. So let me just go ahead and say this up front. The caveat is I'm not saying that you should or should not do any of this stuff. I'm just basically offering up some ideas, some concepts of how you can leverage something that you already have in-house. Okay. All right, we're going to talk about all this stuff right here. All these presentations are, I think, are given to you on a little thumb drive in your bag. You got the same presentation. It says, look in your bag. Do you have a thumb drive in your bag? Is that right? All right, Jim?
Yeah, thumb drive, and then the video will be available later.
Yeah, the video will be available via our website later. But yeah, on a little thumb drive, you should have a thumb drive with something like this. Mine's labeled on the back, it has my name on it. Yeah, it should be on the thumb. This presentation is on there, the whole presentation, so you have it. Okay, and so that way, don't worry about making notes or whatever you have. All right, so we'll talk a little bit about tools. Everybody likes to talk about tools, right? Tools are cool, and we'll talk about the benefits of maybe combining the various different types of testing together. All right, so here's the testing process that I was encountered with. Okay. We had developed 1,100. We went to a company that had no manual test. This is typical for us. Company calls us up and says, "Hey, come in here and automate our regression." And I said, "Where's your regression test at? We have none." That's a problem. If you can't manually test it, how do I want to automate it, right? So again, I did whatever a good consultant does. I said, "We'll write them for you. We'll come in and learn your product, and we'll help you through that practice because we're a full service company that does all this stuff." So we brought my automated guy in who's never written a test case in his life. And, he's an automation guy. He's used to taking other people's test cases. He knew what a good test looks like, and he's rewritten a lot, but he never had to do it from scratch and decompose it. So it was a good learning curve for him. So he and I sat down with the product owner and went through the application, end to end, learned it all, took notes, decomposed it, if you will, into the different functions, features of it. We determined that there's 1,185 test cases in this really awesome tool that we developed our test cases in. You might want to make a note of this. It's called Excel, in case you've never heard of it. Yeah, it's really cool. You can put really cool test case information. That's what we did. They didn't have any tools, nothing. They didn't have any QA representation at all. They wanted to just have our infusion of expertise without the true investment into a QA testing group. All right, so once we developed those test cases, we automated 75% of them. Okay, and then we established an automated run schedule that they were on. So a portion of those tests would run on every commit. So when it committed code, like the developer would write some code, commit code, the automated test, smoke test, would run. Every commit triggered that whole build process all the way out. We'd give them thumbs up, thumbs down. This is all working through Jenkins, in case you want to know the tools, right? I'll tell you the tools along the way I use. All through Jenkins, all right? And we're using Java and Selenium to do this. We established that, we're running along. And then that's when he came up and said, "Hey, man, this is really awesome stuff, man. We want to really see what this thing will do under some load, but we don't want to hire a performance engineer, and we're kind of cheap, as you can tell from not hiring QA test people when we hired you guys, right? We want to leverage that. Can we do that? Is it possible? What can be done?" And so I started thinking about it, and I did some experimentation with it. I took our grid that we had at the time. Let me go to the next slide. Oh, okay. Well, I'll talk about it real quick, high level, then I'll come back to it. So we had this thing called testing grid, and we had 25 nodes on this testing grid. Okay, 25 machines. Okay, virtual machines that we run all our functional tests across. And so we can run our smoke test in about 5 minutes, and we can run like regression level 1 like in 30 minutes to 45 minutes, and then as we go deeper into the regression, it's a little bit longer because it was bigger swath through the application. So we run it on a regular schedule based on what regression path or criticality it was. All right, so I had all that running and everything. So I had my guy say, yeah, let's just check to see what our capacity is on our actual grid. You know, what can it do? I mean, can I run just one instance of the application on a single machine? I mean, I'll only generate, you know, the equivalent of 25 user load on a machine, or can I do multi-threaded on one and generate, you know, exponential number of users across that? And remember, we're using Selenium and Java, so it was free. There's no licensing costs and things like that, right? So we can just do whatever. All right. So this is the question. You know, how do you do load testing with a functional test tool like Selenium? And how many of you ever use Selenium in here? Java, Selenium in here? Yep, we got one. Okay, so I know you've been asked this question before, but I have a little bit. So here's the answer. Short answer is, well, you really shouldn't. It's not what it's designed to do, and I'll tell you why in a minute. But I'm always game to do something cool, interesting, and try to add value where I can, where something don't exist at all. So in my last presentation, I talked about the Facebook motto. The internal motto of the company is doing is better than perfect. So I figured doing something was better than nothing. And that's what I did. And I'm going to tell you what I did and how it all went down. All right, so before we get into this, we've got to talk a little bit about what functional test tools are versus what a performance test tool does. Okay, so it's a little bit different. So think about a functional test tool for a minute, right? A GUI-based test tool. It programmatically controls the browser through the user interface. So you have to launch the browser and you're interacting with those controls on the page through that browser itself. That's how those work. All right. When you're using a functional test tool, typically you use what we call a protocol-based thing. And I know there's some exceptions to what I'm saying, but that's typically what you do. And so basically what you do is you trick the server into thinking that all these requests are coming from a client, and they're not. They're coming from a load generator that you set up and a controller that you set up. So it's a way to generate a lot of load with very few machines, okay? As long as your machines have enough memory, hardware, and stuff like that to do it. And so you can generate, on a small set of machines, you can generate thousands of users, equivalents there, okay? So that's the difference in how they work fundamentally under the hood. So when you run through the front end, if you will, right, through the browser, it requires a lot more processing power because you're actually opening the app. The protocol base, you're not actually opening the app. You're just sending requests directly to the server, tricking it, thinking it's coming from an app. So you can basically bypass the app altogether. That's the idea, concept. All right, so before I could take my regression test and figure out what I want to do with them, I didn't want to just run all these regression tests. I had 1,185 for God's sake, right? Or 75% of that, whatever that number is. I didn't want to just throw all of them at them and keep them all running because I had a lot of data issues that I could run into, locking issues and things like that. So I said, let me go back to my load testing roots and let me do a proper plan on this. And let's put together some techniques and tools for how we can model this thing out. So what I did is I developed a load testing model for them. And I used three concepts here, right? I used what we call a transactional mix, right? So I determined, well, what are the transactions that I want to simulate? Because a lot of my scripts did the same transactions because you have to get through the flow to do the same transactions repeatedly. So I didn't want to just keep replicating that. So I looked at the combination of transactions that I wanted to do that would represent a real-world scenario. So I asked them, hey, do you have any Google Analytics on what the users are using today in production? And so they gave me that model. And so I developed a transactional mix, and I'm going to show you an example of these in just a minute. And then I went through and looked at workload distribution. My load testing guys, you guys do something similar to this when you're planning? You guys kind of go through this kind of process when planning out, looking at your transactions and what you want to simulate, and then look at how you distribute your workload out, right? So these are just techniques that I use. And again, you can use tools to do this, or just what I do. I can do it in Excel or some kind of like a Visio type thing. So, and then I had to look at my user load and data strategy. Okay, so how am I going to get my users on the system? How am I going to get them off the system? Was important. So ramp up, ramp down, and then how long did I want to run this? When I run a functional regression test, I just run it one time. And I say, yeah, pass or fail. On this, I want to run the same task repeatedly. over and over and over a period of time to simulate what a real user would do. So it's not good enough just to throw a bunch of tests at it and say, there you go. I don't know if it worked or not. I want to be more precise with it, a little bit more scientific in my approach and my method if I were going to do this. So this is what I did. These are some examples just so you can see from what I just said back here. This is a transactional mix example from an online banking application. So you see here, this is a scenario, view balance. And I look at which pages are involved with that. And I even look at, well, how many people would exit during that time period? Maybe I want to simulate that process of abandoning the flow in midstream, if you will. I got view balance, bill pay, transfer funds, deposit check. You guys probably do all these things in your online banking today, right? I do. And then there's a lot more. I have ACH wire transfers and things like that as well. And those in the banking business know what this is all about, right? And I also had some other administrative back-end stuff going on that I had to simulate as well. But this is just an example of what I want to put in. And I had to put in some level of think time. In other words, I don't want to go as fast as light, speed of lightning. I wanted to really run it at the same pace that a real user would run it at. All right, so here's a workflow distribution example. Start with the home page, log in, right? And then some people maybe don't log in, they just go do a search. It's like an e-commerce. It's like an e-commerce site here. All right, log in. Some people don't log in, just go do a search, and then they add something to the cart, and it gives you the whole entire process flow here of what the percentages of what people were doing. That helps me define what my transactions are and how many users or what the workload is going to be when I put it to a tool. Here's an example of the user load model. So I'm going to put on, this is a time in minutes, right? I'm going to run a test for 100. I decided to run this test here for 125 minutes, which in my rough math world is what, about 2 hours? And so it took me, from starting out, and I did a few users, a second here, getting to the 100 mark, 100 users, and then I'm going to do a sustained load. We'll keep running the same scenarios of transactions over and over and over during a period of time to represent an hour of under load, and then I'm going to ramp down the same way I ramped them up to get them off the system. So that's kind of how the model looked like. Now, why did I choose 100 for? Anybody have any idea why 100 was chosen for this particular load scenario? Anybody? Yes, okay. The reason why I chose 100 is because you remember I said I had like 25 nodes to work with, so I had a constraint there. Does anybody know how many instances of a browser I can run on one node or one machine? I know that it matters on how much hardware you have underneath you to do this, but anybody have any idea? Do the math and you probably figure it out.
Approximately 250 to 300.
250 to 300 total, or per machine?
Per machine.
You think you need 250 instances of a browser on a single machine?
I mean, if you say 250 users can run around on a single machine,
Yeah.
that means that's 250 threads.
Yeah, exactly. But I'm talking about function. I'm talking about how many users can I run through a functional automation tool like Selenium? How many browsers can I spawn at one time and control on one machine? Right? Think about it like that. Yeah. I know where you're going. You're going to performance test. You're a performance test right there. Yeah. So I didn't know exactly how many we could do. So we did some research. This is interesting. We did some research. Chrome, Firefox, and IE. We did 3 browsers there. This is the 3 main browsers that we're running in. See which one, how they perform. So, which one do you think performed the best between Chrome, Firefox, and which one do you think was overall lower resources and I can put more threads, to work? Which one do you think is best? The most efficient, I guess is the best way to put it. Between Firefox, Chrome, and IE.
Most likely Firefox.
Firefox. Who would you say? Firefox?
I want to go with Chrome, but
Do what? Do what?
I kind of want to go with Chrome, but I'm just going to think it's Firefox.
Yeah.
I think it's Chrome.
You won, Tommy. You didn't read my notes. Chrome. It's Chrome. What we found is Chrome could run like up to like 25 consecutively. No problem. Firefox run about 5, and then IE can only run one barely. So that's kind of our research. We're not gonna run 25 threads, I think the data strategy is best. So what we did is we decided to do a mix between Chrome and Firefox, and we run 5 nodes on each. 5 times 25 gives you 125. People logging on and off. We should do, they have 25 to play with, right? It should give us a sustained load of 100 plus, is how I looked at it, right? How I modeled that. So you see how I kind of backed into that and looked at it. Okay? All right, so these are the things you have to learn, understand about what you're trying to do. Well, how many users are you going to be dealing with? Well, we know we have a finite number, not an infinite number, of users, which is 100, 125. We want to look at the total transactions we want to achieve with that. We want to create the scenarios with the corresponding transactions, and then the percent of total use for each scenario. So how many people do you want logging in versus searching for a product on your page versus, you know, doing whatever. So think about the online banking for a minute. You know, how many people are going to be logging in and just viewing the balance? How many people are going to be actually not withdrawing money, but doing transfers or bill pay? So I think that there's probably a higher number of users, or all the users will be looking at their balance, but then there's a fewer number maybe doing bill pay, a fewer number doing the transfers. All right. So then I figured all that out. That was my load model, my strategy there. Figured all that out, and I came back with a good transactional mix, workload distribution, load strategy there. And then what I did is I went back and said, okay, now what exactly does my inventory do, right? So now I have to find, you know, regression tests that can do or simulate those activities. So, so what you want to do is look at your test coverage, you know, using some kind of a matrix or a heat map. I use a matrix because I had all my stuff in Excel. Identify the scripts that represent a typical workload. Then target the transactions that will produce meaningful data. What I mean by that is, in the performance testing world, simple page navigations are not that intrusive. It's pretty lightweight, right? But where are the heavy hitters at? Where are the things you're really going to learn the most from? It's probably from what we call high I/O, you know, where you're like saving files, reading files, or database calls, right? When you're actually inserting data to a database or retrieving information from a database. Those are going to produce more intense, heavier loads on the system, if you will. So we want to look at that, right, and see which transactions we want to try to hit and make sure that we're actually exercising it the way a user really would. And then what I did is, once I figured out which scripts that I want to represent that model that I created, I then instrumented one of my scripts. I took one of my scripts and instrumented it as an agent. So think about, I got 1,000 or hundreds of automated scripts. Some of them do the same thing. Some of them making the same type of calls. I took one of those scripts and then I instrumented it by putting a timer around the transactions I want to measure. And so I'll show you what I did, the exact code. So this is Java, Selenium. So think about this. I took, say it's login, right? I want to see how long it takes from the time I launch the login page, enter username, enter password, click login. I want to see how long that transaction takes. So I took the script, one of the scripts that did that, and created an agent that would measure that for me. And I wrapped the actual, well, in this case, this right here is just how long it takes to launch Firefox, go to the URL, how long it takes to load the homepage. This is actual example of the homepage. But I wrapped use this concept here to wrap a timer around all the transactions that I want to measure. Okay? And then I basically, and in this case, I just did a quick print line out to the console to see how long it would take to run. But then I took all this information and stored it in Excel, right? And so I would run this on some frequency. As the load is going on, I would run an agent and to give me some data and retrieve it. What I didn't want to do is instrument 1,100 test cases with this kind of stuff in there and produce all these, you know, data, because I have to manage all that data, right? And make it a little unwieldy. All right, so what I did is I had to keep track of and collate all this runtime data. So like you guys who do performance testing, you do all that in your controller. You do all that in the tool, right? It collates all the data for you, takes all that raw data, does something with it. When you instrument a functional test tool, you don't have that capability, so you have to build it. And so I was going to try to build the minimum capability I need to simulate what I needed to. So that's why I did the agent idea, wrapped it in a timer, and I only timed certain one of the transactions, and then I just ran it on some interval, right, frequency to retrieve the information. This is a minimalist tracking approach, but I want to make sure I had enough data to make the results statistically significant. In other words, if I just check one time, right, how long does it take to launch that page or log in, and it's 3 seconds, that doesn't mean it takes that, from the 100th time or whatever, over the hour, how long? Was it the same, and was it within a statistical standard deviation? Okay, that's what I was looking for. All right, page loading time is important to measure to determine user experience, and this is just sort of what I looked at when I was tracking my results. Monitoring tools can be used separately to collect machine data. So in other words, like perfmon, some other things like Dynatrace or other tools that we can use. In this case, we used, I think we used Dynatrace to track some of the data and pull some of those machine level stats off the machine to correlate with our data. All right, so here's what we did. We executed a test suite distributed across the grid. So we executed a lot of tests across the grid. We had a handful of tests that we instrumented with agent level information. Each test node ran 5 browser instances, and we generated a sustained load of 100 plus users at all times for that period of time. And so I actually did all this work that I just showed you in just a few days. Right? And how long would it have taken me to do a real performance test, and actually set it up? It would take a lot longer than that. And that's why we're able to reuse these assets quickly and to set something up and get some values out of what we already had. All right, so the types of the data that I've tracked, the results data, I basically printed out to an Excel sheet the transaction name that I was measuring, the transaction response time, and then the actual system time when the response was reported. And the reason why I did that is so I can later on line up the machine data to the response on the front end, and to make sure that it was all fine. So like let's say we had over time 3 seconds, and then 5 seconds, and then 10 seconds, and then by the end of the test we had 20 seconds to response time. It's not good, right? So then we can go back and look at the machine time, compare it to like Dynatrace reports, and figure out what's going on during that time period to start doing some analysis and me working with the engineers. That was the idea. And guess what we found out? They had problems. They had performance issues. And we were able to do some tuning on the servers with the network guys based on these minimal results that I did here, okay? This is just an example of the results analysis, what it looked like. All that stuff I just said over here, how I built this report, this is what it looked like in Excel. I had an Excel report that tracked the minimum, maximum, average, and standard deviation on all the transactions that I measured that was coming from my agent scripts. All right, now, we have all this raw data, right? All this data we just talked about, all this stuff coming out. What do we do with it? All right, so that's where I came in too. I was able to take all this data and tell a story and say, look, over the period of an hour, your response times were degrading over time. There's an issue somewhere. We got to figure it out, whether it's a machine or a hardware issue, or whether it was a tune issue on the application. We don't know, but that's what we just need to understand there's a problem. And then if you send this thing in production today, just know over time you're going to have some memory leaks and some other issues that may occur. That was the idea. So what we want to do is we want to analyze it, synthesize it, and actionize it. But how? What do you do? And so these are the things that I really did with this particular effort that really helped the manager out. Managers and stakeholders, right, don't like you to hand them a bunch of raw data and say, you figured it out, here it is, I read your test, here you go, what is it? But I came back and said, okay, I read these tests, I was able to present to them what I did, how I did it, and then what I learned as a result of that, okay? But here's what I did. I kept it simple but informative. I made sure it was intuitive and visually meaningful. I did a lot of charts and graphs. Managers like color, charts and graph stuff that represents your story, to tell your story. I summarized the data effectively and efficiently with as least words as possible. I told the complete story, all right, by using very concise verbiage and summaries and things like that. All right, and I try to stay away from these long, big, old, huge reports that are like so heavy you don't know if you should read them or weigh them. You've seen these things before. And so I try to stay away from that and just gave them really a 2-page report and a PowerPoint to go with it and me talking about it. And they said, well, Chris, what do you think we should do? I said, I think we should do some more testing. I think what we need to do is do more testing. I think you need to invest into performance testing, real performance engineering. I just gave you enough. I kicked the tires and told you got some problems and issues. I pointed to a few of them. But there's so many more that we didn't uncover. This is not exhaustive. This is just kicking the tires at best. And I was very open and honest about it. And I didn't recommend that this is the practice they should use going forward. Okay? So the answer was, how low does this concept scale? It doesn't. It's very laborious. It doesn't scale very well. It's very good on little small short windows, and you just want to do something. You want to kick the tires. But it's not exhaustive diagnosis or diagnostic of your hardware infrastructure and how well it's going to run in production. But if you do something like this and you do find problems, it gives you pause and it gives you that leverage you need to say, we might want to invest in going a little bit deeper and further and really exploring, what's going on here. And you see this right here? Short answer, well, it really doesn't scale. And you know me, I like buts. But, we can scale it. And here's how you scale it. I call this a quasi-load testing solution, right? It has a lot of limitations. It's riddled with it. I don't suggest you go out here and try to do this unless you found yourself in a position that I was in. So what you can do is evolve this over time. So you can start with showing some values, what I did. Showed value on a very small scale. And said, we might want to invest in this a little bit deeper. Okay? And instead of generating load with a GUI-based functional test tool, let's switch it up. And let's maybe invest into generating the load using a load test tool, like a load runner or JMeter or whatever your test tool of choice is, right? Let's just switch that one practice. Now we don't have to worry about collating all that data. We don't have to worry about instrument and agent script. We can generate the load that way, potentially, right? And we can continue to use parts of what we've already built if we want to, right? We don't go full blown. We're just going to replace parts and pieces of the practice. And over time, you can build out a formal load testing practice by letting your team grow and understand over time. They don't understand the value of performance testing potentially if you give them to them in a big bang approach, But if you give them to them in small chunks and add value continuously along the way and use your existing stuff and show some ingenuity how you want to do it, you can create a formal load testing practice over time by doing this. Okay, and eventually you can replace the agent script, right? Over time, right? So the idea is to start small and incrementally grow your practice over time and to achieve more and more value. At the end of the day, I've gone to a lot of companies who the performance testing effort is not really adding the value. They generate a bunch of load, a bunch of noise, hand a big old report out, honk a report out to a manager, and then they say, what am I supposed to do with this? Is it good or bad? Should I go or no go? At the end of the day, that's what you're looking for, right? Go, no go. But you want to involve them as a stakeholder to understand certain elements of what you're trying to achieve and why you need to spend $250,000, their money to potentially generate a formal testing practice or a load testing practice in your organization. Okay? And again, all we're trying to do is just start with kicking the tires and you add some value there. Well, kick the tire test reveals something that we don't like, so maybe we should go a little bit deeper and invest more and just continue to go on that way. All right, so by combining these things together, what we found is this. What we didn't know is what would happen when we combine some of the functional aspects of our testing to the load test aspects. We actually found functional defects by doing the load test that we didn't find otherwise. When we run one script at a time, not a problem. Because we'd been running this for weeks and weeks and weeks with no problem. But when we combined several together, we ran into all kinds of issues, concurrency issues that we would not have run into had we not done this little exercise. So that's what really helped us out, realizing really quick, oh, wait a minute, we can find functional defects using a load testing effort, not just tuning opportunities, but true functional defects, where they got to fix things, where it changed things and how they operate. We got into data locking issues. Oh, we didn't think about that because we always log in, do something, log out, log in, do something, log out, And then when we're continually doing stuff, we start seeing records get logged. We start seeing a lot of functional issues in the code that need to be fixed and corrected as well. So there's a lot of benefits to that, right? But here's the biggest benefit, right? It gives you the ability to do some load testing. Right? Well, it's not ideal. And I told them all the way along the way. I said, look, this is not ideal. This is a quasi-load test. It's not a real load test. But I'm doing it because I think we have some value. Gradually develop the load testing practice over time. Right? This is a good introduction to you and to understand and grow yourself into that area and learn how to do a transactional mix and workload distributions and learn how to do all this stuff over time and not have to, be an expert out of the gate, if you will. Right? And then we also found several functional defects can only be found when the application and environment is under a load. Some functional defects will not reveal themselves until it's under load. Functional or non-functional defects, if you will. So we found both, right? And then we showed the value of what performance tests can do. Now, what do you think this company went on to do as a result of what we found? We found some good stuff. What do you think they did? Anybody have a guess what you think this company did? You think they invested in load testing? Of course not! It's too expensive! No, I got their attention and they started talking to me about how do we integrate other open source tools like JMeter and what I talked about. Yeah. Now, whether or not they go, and I left the company. I mean, I moved on to other things as far as the, the consultant. But they did have an introduction there, and then now they are more aware of performance-related stuff than ever, and they do some level of performance testing for every release now. That's a good quality gate. Which one would you rather have? Some quality gate there where we at least say we're going to do some level of performance testing to be very clear about it, or no quality gate at all and just go, I hope, pray to God this works. Cross your fingers when it goes to production. And that's basically what I did, and that's what happened. That's kind of the output, and I run through it quite fast for you guys. This is probably an hour and a half presentation. I condensed it down to an hour, so I apologize if I kind of went a little fast. So. Any questions now for me? Yes.
Yeah, you have mentioned before that there was a question asked to you, can we do UFT scripting into performance and do the same load? What happened after that? Did you find any solution for that? Is it possible end-to-end scenario? Or we could replace
Yeah,
it?
no. I would never replace it with this. So what I did with this, the whole example here, is I took what I already had and just instrumented with some timers and added some reporting around it. That's as far as I went. That's as far as I went with it. What we ended up doing here is looking at and introducing JMeter to generate the load for them. And the next thing was going to be is looking at how we can integrate other performance monitors like Dynatrace separately, right? And monitor, because they had a lot of companies have this issue with their network engineers don't want to give me admin rights to get those counters metrics off their servers directly, so they want to do it. So then you have to do this kind of combined weird thread and kind of compare their results to whatever. So then you actually get two different people doing two different levels of work, if you will. And that works okay as long as you say, okay, what did you see? What did you see? And compare the two together and to correlate our results at some point, right? But it's good because we get to work together. I get to learn more about networking and how the network's engineered. They get to learn about testing and how to do performance testing. And they asked some good questions. Network engineers that I was working with were like, well, what about, what if? They were asking questions I hadn't really thought about, some of the things. And then, of course, I was asking a lot of questions they hadn't thought about, things they should be looking at and considering, right? How do you know? I asked them a question, how do you know this thing's performing well? What triggers do you have? What kind of, tripwires do you have in place? How do you know, And they said, we have none. We just every once in a while log in and check the system and see, but the thing will go down and crash and burn before they were alerted, So it's things like that they were able to put in just as a secondary practice. They were able to put in some really cool, little quick, easy triggers and monitors that would alert someone. And then as we were running, we were able to test out their new triggers they put in place. You see what I'm saying? So it was really cool. It was a really cool experience for me to go through that. But the whole time I always said, this is not a formal load testing effort. This is quasi this is, and we need to evolve it and grow it. So don't expect too much from it, right? I basically undersold and over-delivered what I was trying to do. So that's what I would recommend you do is undersell and over-deliver. Don't oversell and say, oh yeah, this is all you need to do. So, because I told them, I don't recommend this, but here's what I can do. I think it'll work. Let's try it. Give me a few days. Give me a week, whatever. And I did. In a week, I had all these results for them. Less than a week. Make sense?
Yeah. Here, I have another question. Currently, we are dealing with a problem where our application is kind of not like regular application is sitting on our LAN environment. So the APM tool that we are using, Dynatrace, I have recently installed it across all our environment, but it looks like some of the big Indian and little Indian situation where this agent doesn't support our actual WAS servers.
Yes.
And we are not collecting all that data. So basically this pure path dig down is not happening in our environment. So there are no real-time solutions where we could do end-to-end pure path monitoring what would be your solution in that scenario? I mean, if you are in my scenario.
Yeah, you've got I call those blind spots. You got blind spots, right?
Right.
And so I asked this question. I interviewed I needed a performance architect engineer to work for me on a contract. I was interviewing them one day, and they were supposed to be technical. I said, well, what do you look at? What do you monitor when the test is running? What do you look at? What do you monitor? And she said, I look at everything. I said, there's no way you can look at everything. All those blind spots you're talking about. And I said, well, just give me some examples. She went through a whole list of, all kind of stuff that most people look at. And so what I say is this, is if you have blind spots, just know that that's a blind spot. But how do you know if you need to drill into that blind spot or not? Well, you got other indicators somewhere else. So your number one indicator that I use is transaction response time. How does that damn thing behave or respond to my end user request? And if that looks good and I don't see any inherent problems there, I'm okay with a blind spot. You see what I'm saying? But if I start getting really weird transactions, and it's happened to me, I had really weird transactional spikes, and I started going back looking into there, and I found out I had a black hole somewhere. This thing, I did SQL traces, I did everything. Across the WAS servers, all that stuff, right? Could not figure out what was causing that spike, right? Over time. And so what I found out eventually, we had to compare environments to the board. We found it was a bad NIC card. The NIC card was actually hiccuping and causing the delay. So we thought we didn't have any blind spots, but the NIC card gave us a blind spot. And so when we placed the NIC card, everything was fine. But my point is that unless you have a reason to really drill into that blind spot, your transaction response time or other indicators will tell you the health of all that stuff you can't see is okay. And if it's not okay, then you got to figure out how to pull in other tools. Well, it's just somebody log on that circuit and watch it during the time you're running in that area, or whatever. So that's just the way I handle it. So, any more questions? I didn't mean to rush you guys. Okay, sorry. Yes.
All right. So in our company, we have performance scripts, and we have load runner, and we have UFT. So what I've been doing is I've been running performance testing at the same time, just having one iteration of UFT running to make sure that the UI is behaving the way it's supposed to.
Yep.
Making sure that there's no 404 errors or anything like that. Should I implement that practice throughout? Like every time we run performance, we better make sure that we should pull up a UFT? That's the question.
Yeah. So it's a great question. So what I do is, what we call that is user inline testing. Because if you're using load runner, you're using a protocol-based, technology, and you can get false negatives as well as false positives on that potentially. So when you run a test with using load runner, you might get a 2-second response time. But when you log on and do it manually while you're under load, it's like a 4-second response time. So there's some diff. So what you're looking at on the load runner side or performance test tool side is not necessarily that accurate number. So that's going to be the user's experience. You're looking at that as a standard deviation number, right? Of how far it deviates from the normal, mean. So what I'll always do, every single load test, whether it's automated or not, I'll always have a user. During the test, at certain points during the test, it may be, let's say it's an hour, 2 or 3 times during an hour test, log on and tell me what the experience is. It's really subjective. It's not objective. It's not saying go time anything. You log on and tell me how the experience feels to you. Does it feel slow? Does it feel sluggish? And then especially we start hitting some degradation patterns in our load test, definitely log on during that and see what the impact is to the user. And then you get a better guideline. But I would go off of what they say more so than what my script says at that moment. Because sometimes, your scripts run a lot faster, but that damn browser is taking a little bit longer to render, do whatever, and especially different versions. So what I always have users do, I have users on standby during my load test to actually have them do different browsers, different tests to get the overall feel and let me know their subjective, results, if you will. But you're using UFT for that, and that's cool too. So yes, I would definitely continue that, whether it's manual or automated, continue that because it's 2 separate tools and techniques, and for different reasons. You just want to make sure that you're not impacting something. And it's over time though, you might find a correlation between the end user real experience and your script, and you can do some kind of mathematical calculation to figure out what that experience would be that you're comfortable enough with, and you can abandon that altogether. But initially, yes, absolutely, I always do initially. Yep, absolutely. Good. Any other questions? No. All right, funny story, or not funny story, but a joke. How many in here are in QA testing world? You guys work in the QA and testing world? How many in here? All right, show of hands yet. Everybody's just about. Do I have anybody that's not in the QA testing world? Kind of sorted in a minute, okay. So we're going to be talking about our next thing about, agile, DevOps, quality assurance testing, all that kind of stuff. We'll talk about all that together, right? Bring it all together. We've all talked about all these different practice areas, whatever we run. Basically today, we run 8 tracks already. 8 tracks of stuff, so it's pretty cool. So we're going to talk about all this kind of stuff and how you bring it together. But I'll leave you with this. How many QA engineers does it take to change a light bulb?
None.
No, you heard my joke, honey, because you've been in my class before. That's me, right? Actually, in one of my classes, a long time ago, last year.
Yeah.
It takes 0 to change a light bulb. Because we don't change light bulbs, we just report that it's dark. So that's what you need to be doing, just reporting that it's darkness out here somewhere, and then keep doing what you're doing, right? And if it makes sense, try it. And here's the thing. My last session, I talked about running small experiments. This was a small experiment. I told them up front, hey, look, I'm going to try this. I'm going to invest like 4 or 5 days in this thing and see what happens. I could have very well abandoned this and said, no, you don't want to do this. And here's why. But at least I had data and information. And all I did was share to you a case study that I did. The real true story that I did to show you that, when your manager comes and asks really ridiculous stuff, and managers do that, right? You got any managers in here? Jeff Foxworthy makes this comment all the time. He says, you can't talk about rednecks unless you are one, and he are one. So I'm a manager too, so I talk about them in this context. But managers will, they'll come up and ask some ridiculous stuff, and they don't even know half of what they're asking for. They then ask from somebody else potentially. And they ask for all kind of things. So hear the manager out and try to understand what they're really wanting, and then try to come up with a solution that fits that need. And not just blindly go and do whatever they want you to do, but truly have a conversation about it. And that's what I did here. I listened to them, and most engineers would say, no, this is functional testing, I'm not a performance engineer, you're screwed, whatever. And I didn't do that. I listened to the way he said it, and I said, let's try this and see what happens, and it had a lot of value. And now they're doing more performance testing as a result, because they saw the value, and so I thought it was worthwhile, and that's why I shared it. So don't leave here and go out here and say, well, Chris says that we should abandon our performance testing practices and combine all of it together. No, I'm not saying that at all. I'm just saying there's value in doing it, and just understand what that value proposition is and try it out, experiment with it. If it completely bombs, if you don't have the same results that I had, it's probably because you did it wrong. No, I'm just kidding. I'm just kidding. It's probably because it's a different set of variables. There's a different context there that you're just, that's different, because context matters. And that's what I do as a consultant all the time. I look at companies and organizations, and those that work with me and know me will look at things all different kind of ways. I think outside the box a lot of times, and I'll solve problems with some of the unconventional ways and methods. But I don't ever do it big. I want small. I want to fail small. Fail small and then learn and grow and figure out what. There's things that I go into companies all the time and say, we want to try this. I'm like, you don't want to do that. Here's why. Because I've already failed more times than you have in that area. So be careful, that kind of stuff. All right, any other questions? All right, so what do you guys think? Is this helpful? Helpful, kind of, sort of, maybe? It's always helpful to hear something. I go to conferences all the time. I speak at a lot of conferences, and I listen to other guys talk, and I go into, wow, I'm like, it's like a cool nugget of information. I didn't think about it like that. And so if you walk away with any nugget of any kind of information through this whole day, this half-a-day event, then that's really good. We've done our job. We're not trying to save the world, convince you to do anything in any way. We're just sharing information that hopefully will help you with your everyday life. And you're sitting at your desk and making decisions and trying to do a good job. Hopefully some of the things we said will help you guys. So, and with that, we'll, yes, one last question.
Yeah. One more
The
quick
last question.
Right. So this is the question from the previous lecture that you have given to us.
What was the previous lecture?
Agile.
Oh, with who? With who?
You.
Oh, with me. Oh,
Yes.
you were me. Oh,
Sorry.
I can speak to that. I'm like, who are you talking about?
Right. So my question is, for Agile, you have spoken about, well, best practices and all those things, but you haven't talked about Scrum Master. What do you think? Who should be the Scrum Master? Because we know there are lots of people in our DA could be Scrum Masters or architect. Would you think you'd be the best person?
Always a QA guy.
Always a QA guy?
No, it depends. Again, I'm a context guy, it depends. And I think it's okay. So some companies like to do consistency and to have the same Scrum Master, and they actually use Scrum Master as a position title. And I don't like that because you start tying your pay to a position title stuff, it gets wonky. Scrum Master, product owner, it's really a role, right? It's a role, and the role is to facilitate the Scrum process and to make sure that your team is protected. Make sure your team has what it takes to get the job done. And if your BA can do that, give it a try. If your developer can do that, give it a try. If your QA person or whatever, it doesn't matter. Any of those guys should be equipped to be able to do that. But then again, it comes into psychology too, right? You have to understand human psychology and how to keep your team motivated, because Scrum is not about following a recipe, right? It's about embracing a philosophy. And the philosophy is we empower the team. And we give them the tools and we let them work. We let them do a good job and we stand back, we basically enable the team and we stand back and we let them deliver. As a product owner, I don't run into the Scrum team and start trying to interfere. I tell them what my vision is, and I stand back and let them come and demo to me what they produce, something to value. And so I'd say it depends, right? I mean, you got to look at your organization. Some company, I've seen them rotate that responsibility. Everybody needs a chance to try that responsibility out. But I'm having to be a certified Scrum Master, so I've been trained. I know all the little cool techniques. I know all the cool games you can play, But that don't make me a good Scrum Master. That just means I've been to train and learn some of the things. And I've seen bad Scrum Masters, I've seen good ones. I've seen Scrum Masters that were the best of the best and never been to Scrum Master training because they understand people and they understand the philosophy behind it. And that's what Agile is about. It's about the philosophy. It's about breaking your work down in small chunks. It's about being a team. Just because you put groups of people together does not make them a team. Teams produce something exponentially greater than the sum of all parts. That's a routine. And how do you measure that? How do you figure that out? That's all that psychology I'm talking about. That's all that soft, subjective things there. So I'd say don't lock yourself into saying, well, no, it should always be the project manager. That's the biggest mistake people are making now. They're saying project managers are going to be Scrum Masters. We just convert. So what we did, we never really changed. We just flipped the labels. Project manager, yesterday you're a project manager, today you're a Scrum Master. Good luck. Send you Scrum training, you're on your way, right? And that's not how that works, I mean, it's not that easy. And so, and then the organizations ended up with the same results. And they said, Agile is going to work for us. Or it failed. Then you failed. People fail. All problems, like I said in my last presentation, are people problems. All problems are people problems. Tools didn't create the problem. People create the problems. Tools are there to help facilitate whatever it is. And that's all Scrum is. That's all Scrum, Agile, Lean, whatever, XP programming, whatever the Agile, flavor, framework that you want. But Agile is the philosophy, is the spirit behind it. It's to let people work together as teams and become teams, let them gel and bond and be that true team, and let them deliver, and let them have a safe, healthy work environment to deliver. And who you put in that Scrum Master role can be critical. Because sometimes the Scrum Master thinks, especially the project manager, first thing Scrum Master does is he creates a 200-page project plan, and he comes and beats you over the head every day because you didn't meet your milestone. It's not a good Scrum Master, because that's not what a Scrum Master does. It's an upside-down org chart. Scrum Master on the bottom, it's not glamorous, it's on the bottom, holding his team up, supporting his team, giving them what they need to be successful. And whatever that looks like in your organization, who is that person? It could be different people in different, areas. It depends, right? And that's what makes it hard, because we want to make these fast and, steady rules, like recipes, right? Scrum Master should always be A, B, or C. Sometimes it might be D or E. So, that answer your question?
Yeah.
You see me getting to my spirit of Agile. Get ready for my next, the panel talk. So next, we're going to have a break, and we'll go back over to the big room over there, and have a panel discussion. They're going to bring all of us together. All four of us, we've been working together for a lot of years, and so we're goofy, we're funny, we're serious about what we do, we like to have fun. So we're going to come together and we're going to talk about some of these different things and pockets and pieces and so forth. I think it'll be interesting. Should be entertaining at least. All right, thank you very much for coming, and I appreciate it.